In proof number 36, I'm going to start the same way I start all my proofs. I'm going to mark my given information. Angle 1 and angle 2 are congruent, and angle D and angle C are congruent. I like to mark what I'm looking for in a different color, so I'm trying to show that AD and BC are the same. Now my thoughts are that those two small triangles, ECB and ADE, are going to be congruent. So what I'm going to try and do is show that they are, so I can grab those two parts, AD and BC, using CPCTC, or the corresponding parts of the congruent triangles. So going back to my given, I see that angle 1 and angle 2 are the same, which means this triangle AEB is isosceles, so I could draw a cross to EB, draw a cross to AE, and mark those two sides the same. Well, then what I notice is that I already have an angle and a side in those two small purple triangles, and I have another angle here, angle DEA and angle CEB, that are vertical. I can't just call them angle E because I've got an angle E here, 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 and here. That's 4 different angle E's, so I got to be careful when I label. Well, now I see that I have an angle and a side, matching an angle and a side. So those two small purple triangles are congruent, which means I can grab those two parts and I'm done. So now I just have to make sure I write clearly everything that I just said. I started with angle 1 and angle 2 being congruent, and angle C and angle D being congruent because that was given to me. The very next thing that I marked was that AE and EB were the same because of that isosceles triangle from angles 1 and angle 2. So AE and EB are the same because if two angles in a triangle are congruent, then we know the sides opposite those angles are also congruent. And again, you can use the converse of the isosceles triangle theorem here if you wanted to, but I don't ask that you try and remember that, but if you want to save yourself some writing, that would be okay to use here. It's the converse of the isosceles triangle theorem. After that, I noticed that I had some angles, but the angles I needed were the vertical angles right here, which were angle DEA, congruent to angle CEB, and those were vertical. And I know that vertical angles are congruent. Again, don't forget to put about the part about are congruent. If you just write vertical angles, that doesn't mean anything to me. So statement number 4 was, now that I have angle D, angle DEA, and side AE, I knew that those two purple triangles, triangle ADE and triangle BCE, had to be congruent because of an angle-angle side relationship. And if those two triangles are congruent, then I can take any two parts that I want from those two triangles. In this case, I'm interested in AD and BC. And I can say, well, those are congruent because the corresponding parts of congruent triangles are congruent, or as we say, CPCTC. Like all proofs with congruent triangles, I go back and double check. Did I mention the angles that I was using? Angle C and angle D were used in those triangles. Angle DEA and CEB were used in those two small triangles, and I used side AE and EB. So I did list my angle, and my side that I was using, so I can use this for my congruent triangles, which then means I can use CPCTC because of the congruent triangles.